Am I audible? And is my screen visible?
Yeah, you're audible.
Okay. So, hello everyone. Good evening. I am Simit. Today we'll be taking a session on recursion and merge sort. And as you know, this is the last session of our DSA training program. So, okay. So, these are the objectives of today's session. We'll go through each of them one by one. I'll start by telling you what exactly is recursion. Then we'll go through what are subproblems and base cases. Then how to approach to a problem. Uh, then we'll see various problem examples to make you familiar uh, with various techniques. And then Anushka will take over and teach you merge sort. So let's start. So, what exactly is recursion? If we go by definition or simply speaking, recursion is a process in which a function calls itself. Okay. So, if we are defining a function in terms of itself, that is called recursion. Like uh, it is a basically a mathematical uh, concept. Uh, so here is an example. Like I have defined a function fx as f of x minus 1 plus 1. Now, here I have written uh, when x equals 0, fx will be 1, and for x greater than 0, fx will be f of x minus 1 plus 1. So, this part is the definition of the function. As you can see that I have defined fx in terms of itself. Right, I have for defining fx, I have used f. So, now here is a base case when x equals 0, we define fx equals 1. So for x greater than 0, like if we take x equals 1, we can just write f of 1 is equal to f of 0 plus 1. Now f of 0 will be 1. So f of 1 will be 1 plus 1, 2. Now if we need to find f of 2, then we know f of 1 is 2, and then we add 1. So f of 2 will be 3. So, simply speaking, this is what recursion is. So, when we define a function in terms of itself, it is called a recursive function, or when a function calls itself, it is called recursion. Sorry. So, now here is what is subproblem and what are base cases. So, recursion is helpful when we construct a solution to a given problem using solution to its subproblem. Like if we just think that or assume that we have a solution to subproblem. Now we try to find the solution to our problem using uh, the solution to the subproblem that we have assumed that we have. For example, like we need to find n factorial, right? Now we know that n factorial is equal to n into n minus 1 factorial, right? Now our problem here is to find n factorial. Okay, so this is a bigger problem. What we do, we break it into n into n minus 1 factorial. Now our problem has been reduced to just finding the factorial of n minus 1. Now once we have n minus 1 factorial, we can just multiply with n to find n factorial, right? So the problem was to find n factorial. We broke it into a subproblem to find n minus 1 factorial. Okay, so our subproblem is to find n minus 1 factorial. So uh, this is the subproblem. Now next we have base case, right? What is base case? So there will be a case when a subproblem cannot be divided into further subproblems, or it will be illegal to divide it according to natural constraints or or constraints of the problem. Then that case is called base case. For example, let's see here we need to find n factorial, right? So for n equals 0, we cannot write uh, n equals 0 equals 0 into minus 1 factorial. So here 0 is our base case. We cannot divide it into further subproblem. So what we do, we know that for n equals 0, n factorial is equal to 1, right? And for n greater than 0, now we can break it into subproblem and we can find factorial of any number. So this is the base case, because we cannot divide this case into further subproblems. But for n greater than 0, we can just write n factorial is equal to n into n minus 1 factorial, right? So this is what subproblem and base cases is. Now let's talk about how to approach to a problem and find its recursive solution, right? Now there are a few important points to keep in mind. The most important point is to be clear about what your recursive function is doing or returning, right? This is the most important step. Like you need probably it is better to uh, write it somewhere that what exactly my recursive function is going to do, or what exactly is it going to return. Okay, so we know that a function either uh, returns something, or if it is of void type, it doesn't return something, it does something. Okay, so the most important step is this, that we need to be very clear about what exactly our function is going to do, or uh, it is going to return. Like I'll show it in a few examples. uh, why is it so important? Then what we do, then we try to break the problem into sub problem. Okay, for example, we have a problem, then we try to break it into a sub problem. Then we assume that we have the answer to the sub problem. We make this assumption that let's suppose we have the answer to a sub problem. Now how are we going to construct the solution to our problem using the answer to the subproblem that we have? So here is an assumption that we make, that we already have the answer to our subproblem. Now our next step would be to construct the solution to the problem using the answer of the subproblem. Okay. Now after we have done this, uh, we need to think about the best cases. Now this depends upon the question or natural constraints. Like natural constraint can be like, in case of factorial, uh, we cannot write 0 factorial as 0 into minus 1 factorial, right? So that was a natural constraint. But sometimes in problem, uh, while looking at the problem, it will be easier to think of base cases. Okay, so these are some steps. Now let's see some examples. Now these are very simple examples, but it will make it very clear how to approach to problem. Wait, I'll create a Jamboard and I'll show you. Okay. Now, okay. So we'll code it later. We'll just first let's see what our problem is. Now first problem was to print numbers in this following order: 1, 2, 3, 4 till n. Okay, so uh, let's see what exactly is our problem. Our problem is to print 1, 2, 3, 4 till n. Okay, now now the first step would be to define our function. Like let's define our function that uh, this function f. Okay, let's write it in this way. Void. Now this function f will take a parameter and it prints the number from 1 to n. It takes n as parameter and it prints the number from 1 to n. Now here is an important step. We are keeping a faith on this function that yeah, once we give n, it will print 1 to n. This is our faith. So this is one of the most important thing, to keep faith on your function, that yeah, once we have provided it with n, it will print from 1 to n. We don't think about how it does or why it does. Like we just have faith on it, that yeah, our function is like this and it will print from 1 to n. Okay, now 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 let's see that what if I print till n minus 1, okay, and then I print n. Okay, so what I'm gonna do is I'm gonna just write f of n minus 1. Okay, I called f of n minus 1. Then what I'll do, I'll just print n. Okay, so yeah, it's done. So let's see what we have done. We have kept faith on our function. Like what our function is, our function does that if we pass n as parameter, it will print till it will print from 1 to n. Now if I pass f of n, if I pass n minus 1 in f, what is it's gonna do according to the definition of the function? It will print from 1 to n minus 1. Okay, so yeah, we have the faith that it will print this. Okay, this is our faith. We don't think about how it's gonna do, why it's gonna do. We just have faith that yeah, it's gonna work. And then what we have done, we have just printed n. Okay, so yeah, it's done. uh, but here you need to think about the base case as well. Okay, so here I have defined my function. This is the definition of the function. Okay, now I need to think about the base case. So we are starting from 1. Okay, and we are going till n. So if we are passing 1 in the function, okay, it should just print okay, wait, I'll make it more clear. Okay, so this was our function. I called f of n minus 1. I had faith that this will be done. My function will print till n minus 1. Then I'll print just and I'll just print n. Okay, this was our function. Now we just need to think about the base case. Now if someone passes 1 in this function, right? Now if n is equal to 1, okay, what are we gonna do? We just need to print n, print 1, and then return. Like So we know that return statements, whenever this statement is encountered, the function terminates there only. Okay. So let's see how it is gonna work. Like, let's suppose I have passed 4, okay, in this. Now it will encounter f of n minus 1 first. Okay, so this was our function. Now it will call here n was 4. Okay, it will then call f of n minus 1. So here I've called this was our function. Then this function calls f of n minus 1. Then itself, it calls itself. Then in 3, what it does, it calls f of 2. Then in 2, when 2 is passed, it calls f of 1. Now when n equals 1, what we have done, we have printed 1. So let's suppose this is our console, or this is our output window. So now what will be done, like when n is equal to 1, we have printed 1. Okay, so now these statements won't be executed at this level because return statement is encountered here. So this this will clear out. Okay, now what happens, since at this level this statement was called. Okay, now we go to the this statement for this level. Then we print here n was equal to 2. Then uh, this is also deleted. Okay, so I'll I won't go much further into about these boxes that we are creating. This is called a stack. Okay, so whenever we uh, define recursive function, it actually runs and creates various levels of stacks. Okay, now at this level n was 3, so 3 will be printed. Then this will also be deleted. Now at this level n was 4, so now this statement will be encountered and 4 will be printed. So this was it. Okay, now our second problem was like we have passed n and we need to print in this order: n minus 1, n minus 2, n minus 3 till 1. Okay, now what are we gonna do here? Our faith on the function is that whenever I pass n in the function, it prints from from n to 1. This is our faith. Okay, so whenever we pass f of n minus 1, what will it do? It will print from n minus 1 to 1, right? So here we'll define our function as like uh, f int n. Now what are we gonna do here? We will just print n first, then we will just call f of n minus 1. Right, it's simple. We had our faith that I'll just when I'm done printing n, then I'll call f of n minus 1. And as we know that our faith on the function is that when we pass n minus 1 in f, it will print from n minus 1 to 1. Okay, so this is it. And here also we'll have the same base case. If n equals 1, just print 1 and then return. Okay, so I'll try to code it. Wait, let's see how it works. So I'm using online compiler for this. Now our function is void. Let's see. For example, let's assume our function is print, and it takes a parameter n. Now we need to print from 1 to n. Okay. So here we write base case that if we pass n equals 1, then what are we gonna do? We will just print 1 and then we will return. Okay, just will return here. Now we need to print from 1 to n. Okay, so my faith is that I'll if I pass n minus 1, then my function will print from 1 to n minus 1. Okay, this is my faith. So okay, I'll call just n minus 1. This is the name of the function. Okay, now I'll just okay, let's keep it f. I will be confused. Okay, now this statement will print from 1 to n minus 1. Then after printing from 1 minus 1, we'll just print n. Okay, we need to change the line also. Okay, right. Now we will just call print 10. Let's see. Okay, sorry. Okay, so here it is. Is it visible and audible? Okay. So here it is. Uh, this was our faith that if we pass n minus 1, then our function will do this, and then we just printed n. So this is very simple. Now if we need to print from n to 1, like then what we do, we just first print n. We just what we do, we just first print n, and then we call f of n minus 1. Okay, so yeah, so it will print from 10 to 1. So I hope it is clear. If anyone has any doubt, please you can ask now before we move to the next part. uh, is it clear? uh, if it is not, I can explain it again. Okay, great. Now our so this is done. Now our next problem is to find n factorial. Okay, so this is also very simple. Let's see. Now the most important step to be clear about what our function is gonna do. Okay, let's suppose our function is going to return n factorial when we pass n. Okay, so this is our faith. This is our faith on the function. Okay, this, and it is gonna return something. So it will have a return type. My function is factorial. It will take a parameter int n. Now, now we know that n factorial is equal to n into n minus 1 factorial. Right. Now let's assume that we have solution to this subproblem. This is our subproblem. Let's assume that we have our solution to this subproblem. Then what are we gonna do? We can just write int now answer is equal to n into sorry n into factorial of will pass n minus 1. Okay, why? Because our faith is when we pass n, then we get n minus 1 factorial. Sorry, when we pass n, we get n factorial. Then if we pass n minus 1, then we'll get n minus 1 factorial. This is our faith. So from here, I'll get n minus 1 factorial, and I have just multiplied it with n to get our answer. Now we just return this answer. Okay. Now we need to think about base case. If n is if now our base case will be, for example, if we pass 0, then 0 can't be divided into further subproblem for this case for finding factorial. Okay, so it will be our base case. So if n is equal to 0, then what we do, we just return 1. Okay, because for n equals 0, 0 factorial is always equals to 1. And let's see how it works. Okay, so here now I have just defined int factorial. Okay, if we pass n, then we will get n factorial. Okay, let's forget about base case right now. Now answer is equal to n into factorial of n minus 1. Okay, now we just simply return the answer here. Now since we know that if we pass n minus 1, our function will return n minus 1 factorial, because that was our faith on this function. Now we just need to think about the base case. Sorry, if n is equal to 0, then we just return 1, because 0 factorial is always equal to 1. Okay, now let's print it. Factorial of 5. Okay. Let's see. It is 120. Or we can do factorial of 10. It is this 3628800. So I hope this is also clear. It was very simple. Okay. I hope you don't have any doubt. So our third problem is to find nth Fibonacci term. Let's see what Fibonacci series really is. So Fibonacci series is the first term is 1, then the second term is 1, and we just add two successive terms to get the next term. So we'll add these two, and then we'll get 2 as the next term. Then we will add these two. 1 plus 2 is equal to 3. Then we will add these two to get 5. Then we will add these two to get 8, and so on. Okay, so this is our first term, this is our second term, this is our third term, this is our fourth term, and so on. Okay, so the question is to find nth Fibonacci term. Okay, now the first step to be clear about what our function is going to return. Let's suppose our function is going to return Fibonacci of n when we pass n. Okay, so it will return Fibonacci of n when we pass n. It will return Fibonacci of n minus 1 when we pass n minus 1. It will return Fibonacci of n minus 2 when we pass n minus 2, and so on. So here we know that let's if we see about if we see this term, and this is the sixth term, we know that the sixth term is nothing but summation of the fifth term and fourth term. Once we have these two terms, we can form the sixth term. Now if we see the fifth term, this term, it is nothing but the summation of fourth term and the third term. All right, 2 plus 3 is equal to 5. So we can just write, we can just observe that any term is just the summation of previous two successive terms. Okay, now if we have the fourth term and the fifth term, we can always find the sixth term by adding these two. Okay, so let's see. Now our function returns something, so this will have a return type. It will take some parameter n. Now our faith is if we pass n, then it will return Fibonacci of n. Okay, so so we know we need to find the nth Fibonacci term. So we know that at this like our answer will be, we need to find nth Fibonacci term. So if we have n minus 1th term and n minus 2th term, then we can have the nth term, right? By just adding these two, we can get this. So our answer would be fib of n minus 1 plus fib of n minus 2. Okay, and we just return the answer. Okay, now it is as simple as that. Like our assumption is this will give us the n minus 1th term, this will give us the n minus 2nd term, and our answer will be just sum of these two. So let's think about the base case. Base case is when we need to find the if we if someone asks first term, we cannot go beyond this. Okay, or if someone asks us second term, we cannot go beyond. We can find the first term, but we cannot go beyond this to find n minus second term. So if n is equal to 1 or n is equal to 2, what we do? If n is the first or the second term, then we just return 1, because the first or the second term is just 1. So this is our base case, and yeah, we are done. So let's see. So this is our function. Now our answer, if we need to know the nth Fibonacci term, that will be the n minus 1 Fibonacci term plus n minus second Fibonacci term. We don't need to think about how we are going to get this or why it is returning this. We just have our faith, blind faith, okay, and we just return our answer. And we'll write the base case if someone asks the first term, or if someone asks second term, we know that first or second term is 1. Okay. So let's see. If we need to find a fifth Fibonacci term, so I'll pass 5, I'll print it. Okay, let's see. Is it same? Okay, the first term is this, second is this, third is this, fourth is this, fifth is 5. Okay, sixth will be 8, and seventh will be 8 plus 5, 13. So let's see. Seventh term. Okay, it is 13. Okay. So these were some simple problems. Now the fourth one is a standard problem. Okay. The problem is that there are n stairs on a staircase. A person is standing at the bottom and wants to reach at the top. The person can climb either 1 or 2 stairs at a time. Count the number of ways the person can reach the top. Okay, so let's see. We have a staircase like this. Okay, this is the bottom, or this is level 0. We have n stairs. Now from here, the person can either take 1 step or either 2 steps. Now from here, it can either go here or here. So at each level, it can either go 1 level up or 2 levels up. Okay, so we need to find the number of ways to reach n. We need to count the number of ways to reach n. Okay, so this is the 0th level, and the question says that we have n stairs, and at each level we have 2 options. Either we can take 1 jump, we can take 1 step, or we can take 2 steps to reach here. So this is the first level, this is the second level. So we can either go here or here, and from here, from the first level, either I can go to the second or the third. From here, That is, this is nth level, this is n minus 1, this is n minus 2. Okay. From here, I can either go here or to the nth. So we need to calculate total number of ways to reach n from 0. Okay. So let's see how are we gonna solve it. Uh, let's define our function. Our function returns number of ways to go to reach nth stair when we pass n. Okay, great. So if we pass n minus 1, then it will return number of ways to reach n minus 1. If we pass n minus 2, then it will return number of ways to reach n minus 2. Uh, okay, according to the definition of the function, isn't it? So let's suppose this was our staircase. Okay. Now let's suppose we are at this level. Now we can reach to n from either here or from here, isn't it? But we can reach n if we take two jumps from n minus 2 level or one jump from n minus 1 level, isn't it? So to reach n, we can take one jump from n minus 1 or two jumps from n minus 2 because both are legal. According to problem, we can either take one jump or two jumps. So let's suppose we have a number of ways. We have the number of ways to reach n minus 1. Let's suppose we have number of ways to reach n minus 1. And let's suppose we have number of ways to reach n minus 2. This is our assumption that we have these two. Okay. Now, number of ways to reach n minus 2 plus number of ways to reach n minus 1. This will be equal to number of ways to reach n, isn't it? Like once we reach here, we can either take two jumps, or once we reach here, we can either take one jump. So we will reach here. So our function will be like int number of ways. It will take parameter n. Okay. Our answer, int answer, will be number of ways to reach n minus 1, number of ways to reach here, plus number of ways to reach here, plus number of ways to reach here, to reach n minus 2. And then what we do? We just return answer. Okay. Now let's think about the base case. For example, n is 2. If we have n as equal to 2, then from 0, we can either reach 2 from here or from here. So for n equals 2, if n equals 2, we know that we can reach 2 in two ways. So we will return 2. If n is equal to 1, okay, if n is equal to 1 here, if n is equal to 1, so we just have only one stair. So and we are here. So to reach 1, we have only one way to take step of 1. So if n is equal to 1, we just return 1. Um, so these were our base cases. Now we can just write them here, or like let's suppose I've written it here. Okay, I'll write it in the code. It will be much clear. So number of ways to reach n. We need to our function returns number of ways to reach n. Answer will be number of ways to reach n minus 1 plus number of ways to reach n minus 2, and we just return the answer. Now if n is equal to 1, we have only one stair and we are on 0th level, so we can just take a step of 2 and reach there, so we will return just 1. If n is equal to 2, we will just return 2. Okay, so I want to know number of ways to reach if n is 5, means number of steps is 5. Sorry, number of stairs is 5. Now we need to know number of ways to reach the 5th level from 0th level. So it is 8. You can count it. If n is equal to 3, let's see, it is 3. How? Okay, if n is equal to 3, this is first, this is second, this is third. So we can reach here. First, from here we can either go there or there, and from here we can go here. So the first way is to go here and then here. Second way is to go here, and then from here I will take a step of 2, and the third way will be to take a step of 1, then to take a step of 1, and then to take a step of 1. Okay, so 3. Total number of ways will be 3. You can verify it for the larger cases. So this was one extra problem, but since I've already taken much time, you can try on your own. This is a good problem. I'll explain the problem and then you can try on your own. So if we if you are asked to find a to the power n, what sorry, what a naive solution will be. Naive solution will be to iterate from int I equals 1 to I is less than equals to n, and I plus plus. Okay, for example, here we have our answer equals 1. Now each time what we do, we multiply answer is equal to answer into a. So as we see, if n is equal to 1, then answer will be equal to answer into a. So a to the power 1 is equal to a. If n is equal to 2, then this loop will run 2 times. Then answer will be, first time answer will be answer equals answer into 1. Sorry, a into 1. So first time answer will be a. Then in the second iteration, answer will be, now answer is equal to a. So a into a. then it will be a square. So a to the power n is equal to a square. So we can see that to find a to the power n in naive approach, we can just we need to uh, iterate n times. Okay, so the complexity is order of n. But we need here I want to reduce the complexity, and I want to find a to the power n in log n time. Okay, so this you can try on your own. Now Anushka can take over, or if you have any doubt, you can ask in any of the things that I told. If you have any doubt, please ask. Uh, am I audible? Don't make me feel like what
Yeah,
professors
you're
feel.
audible.
Okay, so yeah, so if anyone has doubt, you may ask, or Anushka, you can take over now for the merge sort. Great, then I'll stop presenting now.
Okay, so thanks, Simit. Let me present my screen first. Okay, so hi everyone, I'm Anushka and I'll be taking the merge sort part of today's session. So in week 4 sessions, we did some sorting algorithms like bubble sort, selection sort, then insertion sort. Those were all time complexity O of n square, right? My mic is on. Yeah. So those were all of time complexity O of n square. So n square is mm, kind of bad time complexity, I can say, because if you have 10 to the power 5 elements in an array, you'll need 10 to the power 10 operations, right? That's a huge amount of operation. Huge amount of operations are required. So we have some faster algorithms which perform the sorting in O of n log n. And we have many such algorithms like merge sort, we have quick sort. So we'll be dealing with merge sort in today's session. So before also these things are quite important if, from interview point of view, because they expect you to know one n log n sorting algorithm. So before I explain what is merge sort, let me try and explain how we merge two sorted arrays. So suppose you have two arrays. Suppose you have two arrays. And you're trying to merge them and sort them. Like you want a sorted merged array after doing the operations. So what you can do is maybe just append this second array at the end of this first array. Suppose let's say this is array 1. So this is array 2. So you can just append this array 2 at the end of this and then apply some kind of sorting algorithm on it, right? So that can be one way. But think that these arrays were already sorted. Like you have one sorted array and another sorted array. So suppose you have one sorted array like, let's say something like 2, 7. So this is one sorted array. It's in sorted order. And you have another sorted array. So let's say this is something like So you're trying to merge these two arrays, and the resultant array should be sorted. So like I said, you can just append this second array at the end of it and then apply some kind of sorting algorithm. But that will take O of n for appending, and then for sorting, if you are using some fast algorithm, then it will take O of n log n, or for bubble sort, selection sort, it is going to take O of n square. But since the arrays are already sorted, we can take advantage of this fact. Like it's already organized in a way, so we can organizing something out of two organizing things is much easier. So we are not going to do that, like append it and then sort the whole thing again. We are just going to take advantage of the fact that these two arrays were already sorted from before. So let me create the resultant array. Like we'll fill these spaces. So there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 11 elements are there. 1, 2. So let's have two markers here, like one is I and one is J. So since it is sorted order, we first need to check the first elements in the list. Like these things cannot be your first element here, right? Because you have some smaller elements at the beginning itself. So you are going to check the first elements of both the arrays. So we are using some kind of markers here for understanding which one we are checking. So let's see, we have 1 and we have 2. So which one is smaller here? We are sorting in ascending order. So which one is smaller here? So 1. So my 1 should come here in the resultant array. 1 should be the first element. So we have used up 1 now. We are not going to use 1 because we have used it. So my J becomes the next element. So for filling the second element in the array, I'm going to check between my ith element of array 1 and the jth element of array 2. So 2 and 3. Between 2 and 3, 2 is smaller. So I'm going to write 2 here. I have used 2 now, so I don't need it. My I becomes here. I comes here. So the next step, I'm going to check between 3 and 7. So 3 is the smaller one. 3. So I'm using this, so I'll strike it out, and next my J becomes 4. J comes to 4. So I'm checking between 7 and 4. So which one is smaller? 4. So I'm striking this out as well. My J comes here. So next I'm checking between I and J. So ith element is 7 and jth element is 9. So which one is smaller? 7. So next, between 32 and 9, it will be 9. Between 32 and 75, it will be 32. Between 56 and 75, it will be 56. Here, 75. So J has finished. So after J has finished, I have two things still left. So I can just place them after this, right? Like only these things are left and these are already in sorted order. So after I have written 75, I can just place these two one by one. So 88 first and 90. So I merged these two arrays and I got an array that is in sorted order. This is in sorted order. So can you tell me what was the time complexity for this, for both this merging these two arrays? Can you tell me what was the time complexity for this? Can anyone say? No, it takes actually O of n. If you see, at each step, I was filling one element, right? At each step, what operation I was performing? Checking two elements and placing it. So how many operations did I perform? So I performed these many operations from here to here. For the first operation, I compared between 2 and 1 and then placed 1. So this was my one operation, right? This was one operation. My second operation, I put this value in the array. My third operation, this value. So it took how many operations? Total 11 operations, like the length of this resultant array, right? So it's taking linear time actually. So it's going to be O of n for merging. So this was merging two arrays and it takes O of n linear time. So this was merging. Now let's come to merge sort. Merge sort is a sorting algorithm. Like I said, it follows divide and conquer technique. So we are going to divide our problems into some sub problems and we are going to solve those sub problems and combine to get the final result. So we have a problem. We are going to divide it into some sub problems, smaller and smaller sub problems, which will be solvable by us. We will solve those sub problems and then merge those results, like combine those results. So that's divide and conquer technique. So in merge sort, what we do is divide the array in half and then we try to conquer that thing. So suppose we have an array. So let's talk about first divide and conquer. What we do is we have some kind of problem. We are dividing it into some sub problems. So we'll try to divide it into as many sub problems as possible until they become solvable. And then we are going to try and solve them. After we have solved them, will solve these things here. And after we have solved them, we are going to merge the results. We are going to merge the results. And then we can get the final answer this way. So we do similar thing for merge sort. In merge sort, suppose we have an array. So suppose we have an array like 45, 12, 5, any numbers. So we have these numbers. What we are going to do is to make our life simpler, to make our work easier, we are going to divide it into some sub problems. So let's say that we are having this array and we are dividing it by half. So we are dividing it by half. And now we have these two arrays to sort. So now we have divided the problem into this. So we are saying that if somehow we can sort this half of the array and this half of the array, then we can merge this thing like I showed here. We can merge this thing in O of n time. So if we are getting somehow we are getting this half of the array sorted and this half of the array is sorted. So if we are somehow getting something like 5, 9, 12, 45, a sorted array this side, and another sorted array this side like 23, 32, 70, 90. So we can merge these things, two things, into this entire resultant array that will be a sorted array. So we know how to do that. We saw just now, and we can do that in O of n time complexity, right? So now we are thinking that maybe we can divide it into even more simpler sub problems, right? So let's divide these this array into half again. So we have 45, 12, and we have here 5 and 9. Now I think we can divide it in even further. So we are going to have 45 here, and we are going to have 12. And if I'm dividing this as well, so I get 5 and 9. So this side also I can do the same thing, like 70 and 90. And 23 and 32. So again, I'm dividing into smaller sub problems, that is 70 and 90. So what I did was I had this array of length 8. So I'm saying that somehow if I have sorted the first 4 elements and sorted the next 4 elements, then I can merge them. I know how to merge them in O of n type. I know that thing. So I'm dividing it into these two sub problems. Now I'm saying, excuse me, now I'm saying that for 4, this array of length 4, I can divide it into further 2 element array. Array is containing 2 elements only. So I'm going to do this. So if I have somehow sorted this part and this part, I can just merge them. Like if I have got 12, 45, 9, 5, 9, I can merge those things. In this case also, we are dividing it into 2 sub problems, and from here we are dividing it into 2 sub problems again. So after I get single element in an array, we get a single element array, we cannot divide it further, right? So we cannot divide it further, but this itself is sorted, right? 45, if I have an element, if I have an array of length 1, it's sorted by itself, right? 45 is already sorted. So this is also, we can consider this as a sorted array. We can also consider this as a sorted array. So now we can merge these things. We can use the same merge algorithm that we used here. Like I'm taking one I here, j here, comparing, and increasing one point, increasing my marker by 1 whenever I'm putting the value. So we can use, do the same thing here. So I'm going to merge 12 and 45 here. So it's already sorted. So my I will be here, my j will be here. So comparing between I and j, 12 comes first, and then comes 45. So I'll mark it. Then after that 45. So 45 here. So I got this. Now for this too, let me merge again. It was already sorted actually, but if we use the same technique, then first my I and j, comparing, I get 5 first. So 5 goes first, and then comes my 9. Same here. So okay. So I shouldn't go at this side first. Let me just do the thing here. So I have these two sorted arrays here, array 1 and array 2, and I need to merge these two sorted arrays. I need to merge these two sorted arrays. So in the similar way, I'll have one I and one j, and I'm going to compare. So 5 comes first, 5 here. So after that, j becomes this, and then I'm comparing 12 and 9. So 9 comes first, 9. After that, this is completed. So I can just put whatever is left here, 12, 45. So same here. If I merge, first comes 23, then comes 32, then comes 70, then comes 90. So after I got these arrays of length 4, these are sorted. So I can just merge them into a sorted array. So first comes my 5, then comes 9, then comes 12, then comes 23 here, then comes 32. After that comes 45, and then comes 70, and then comes 90. So you can see that if you see, is it visible? Oh, okay, let me zoom it. So my array was of length 8. I was dividing it into half. So half becomes 4 length. So that sorting this becomes easier for me. So I'm dividing it in even further into 2 elements, then 1, 1. After it cannot be divided any further, we are solving it. So how we are solving it? And we are merging it and solving it. So we are merging 12 and 45. So it's in sorted order. Again, sorted order, sorted order, sorted order. So after we got these two arrays of sorted in sorted order, we can merge them to get another the resultant. Same here, same here. So this is divide and conquer for merge sort. Okay, so the array is repeatedly divided into half until there is one element left in each subarray, and then the subarrays are then merged in sorted order. So this thing takes, the time complexity taken by this is O of n log n. So the time complexity takes so this is for best case, worst case, average case. In all three cases, it takes O of n log n, and the space complexity taken by it is O of n, because we are storing this array somewhere, right? We're storing this array somewhere while sorting it and merging it. So it's taking O of n space. Time complexity O of n log n, I'll explain. There's a really good article that you can see, this Khan Academy article, analysis of merge sort. You can check that out, search this out. Let me explain as well. So we saw that merging takes O of n. Merging two sorted arrays into another sorted resultant sorted array takes O of n. Now, how many steps are we taking here? So suppose, let's say we have these n elements, some n elements here in the array, and we are merging these n elements. So suppose that thing takes c of n. So it takes c of n time. We are considering that this thing takes merging and this solving this thing, like it's divide and conquer. So solving this thing takes c of n time. So C is constant, so doesn't matter. It's O of n in order of O of n. So C of n times. Now, if I'm dividing it into half, I'm dividing the length of the array by half, so my number of elements becomes half, n by 2. So I have now two such arrays. I have one and another one. So I have two such arrays having length n by 2, right? So I have here one array of length n by 2 and I have another one n by 2. So if I'm doing the same thing here for n, it was taking me C of n. So for n by 2, it should take me times C of n by 2, like C into n by 2. C is just a constant. You can just ignore that and think it as n by 2. So if it was taking me n operations for a length of n, for length of n by 2, it was going to it'll take me n by 2. So C is just a constant. You can ignore that. Then we are again dividing the problem in dividing the array n by 2 into n by 4 length n by 4. So here you can see that for n by 2, this array, it was taking me C of C n by 2 operations, but I have two such arrays. Right? Let me clear the space here. So for an array of length n, one array, this was one array of length n, it was taking me Cn operations. Now I'm dividing this into two sub-problems, two sub-arrays of length n by 2 and n by 2. So if it was taking for n or Cn operations, for n by 2, it will take me Cn by 2 operations. But now we have two such arrays. So I need to multiply 2 here. So total number of operations. So that is also Cn. 2 and 2 cancels each other out. Again, I'm dividing into n by 4. So I'm dividing this array of length n by 2 into half. So it becomes now length of each of these sub arrays becomes n by 4. These are my sub arrays now of length n by 4. So I have 4 such sub arrays. So it will be 4 into Cn by 4 operations needed for that, for merging these things, for solving these things, these sub problems, merging and solving and making it into n by 2. Like when I'm merging, I'm going back this way. So this is also giving me C of n. So for 8, the next step, it becomes 8 into C of n by 8. So all of these things are going to give me Cn at the end. So after all my division operations, after I have performed all this division into two sub-arrays, at the end I'm going to get this length, array length of 1, right? So that was my base case here, array length 1. So I'm going to get how many such arrays? N, of course, right? The first, my first original array was of length n. So how many such arrays do we need of length 1? N. So this will be n into C. So Cn by n. So C. So this is also Cn. So total, how many operations did we require for this? So total we required all the sum of all these Cn's. Like at each step, the total of these. So how many steps did we need for this? Like there are going to be other steps here. So that will be equal to the height of this tree. Like how many layers we went inside. So here 1, then 2, then 3. So the height of this tree is log n. So we are performing this Cn operation log n times. So it actually for 8, dividing takes me so from 8 to 1, if I need to find from 8 to 1, how many steps, how many layers did we cover? 1, 2, 3, 4. 4, right? So this takes log of 8 base 2 plus 1, right? So here for this tree here, my height will be for n, my height will be log of n plus 1, and we are multiplying Cn with it. So we are performing Cn into log n plus 1 operation. So we can ignore the constants here because they are the lower order terms. So my time complexity becomes n log n. So you can check this article out. It's really good. Maybe you'll understand if you did not understand here. This one, I can give you the link. Okay, yeah, I expected this question. Like, if the total number of elements is 9, then how could we divide it into 2 parts? So in that case also, we are not going to have any problem. I can show you that. Let me come here. So suppose we have 9. Eight and 1 9. So first, I can just divide unequally. It doesn't matter. We are just creating some sub problems that will be easier for us to solve. So we can have here 4 and we can have here 5, or maybe the other way around. We can have 5 on the left and 4 on the right. So let me take some examples as well, or maybe I'll just show for the smaller things, or otherwise it'll be too long. So for 4, then we are dividing it into 2 and 2 length. For 5, we can again do it for 2 and 3. So here we can go for 1 and 1, 1 and 1. So here also I can go for 1 and 2. So I need one more step here. Like, I can divide this into smaller sub problems. The other ones I cannot break them into smaller sub problems because they're already the simplest one case. So I can divide this into again. So yeah, done. So now you can just combine these two here. Like, you can combine these two first, merge them after sorting. So it will be sorted. So one element means it's already sorted. So you can merge these two. Then you can merge these 3. Then you can merge here, and then you can merge this whole thing. So could you understand how we are dealing with odd number of elements? So I think you have understood. If not, you can say in the chat box or maybe unmute and speak as well. So I've written the code here. You can check that out, but I'll show separately since it's not that easy to read from here. So first one is for merging. So for merge sort. So merge sort, what I'm doing is merge sort. So this is my merge sort function. And I'm sending this array. I'm sending this array of length 8, suppose. You can take anything here. I'm calling this merge sort function, and this merge sort function takes the array as input, as array as the parameters, and it has the lower bound and the upper bound. Lower bound means this one, like this is my 0th index and this is my n-1 index. So these are my lower bounds and upper bounds. So I'm just telling the from where to where I want to consider in the array. So lower bound and upper bound. So my middle will be L plus U by 2. So now, so how long are we going to divide this thing into sub problems? How long are we going to divide this into sub problems? As long as I have this only one element, or maybe you can say that the L for this, and so lower bound cannot be greater than upper bound, right? Or not even equal to upper bound, because if lower bound and upper bound are equal, in that case, I have only one element, right? This is L and this is U. So this is the portion of the array that we are considering. So we cannot have lower bound greater than or equal to the upper bound. So this we cannot have. So lower bound must be less than upper bound. So in that case, suppose we have a lower bound as 1 and upper bound as 2. So we are considering only this segment of the array here in this function, inside this function. So only then can we split it. Like after that, we cannot split it. One element we cannot split. And after that, if U is greater than L, then we are not considering any array at all. So we are splitting it first. We are finding the middle position. So suppose my L is here, somewhere here. My L is here and my U is here. So my middle portion will, I'll get the value of the middle index by L plus U divided by 2. So here I'll get L plus 2 divided by 2 here. So you can take L plus U by 2. You can take seal or floor, doesn't matter, because you just need to divide it into sub problems. Doesn't have to be the exact middle. So we are saying, so that's recursion thing that we learned. What we learned is that we are having faith on this thing, that if I call this merge sort function, it will somehow give me this portion of the array in sorted order. So if I pass from it is 0, suppose let's say this is 0, 1, this is 2, this is 4, 3, 4, 5, 6, 7, and 8. So if I send pass in my function the array and the upper bound and lower bound, that is giving me which part of the array I'm considering. So if I send this portion of the array to my merge sort function, call my merge sort function by passing this, it will somehow return me the sorted form of it. So if I pass this, it will somehow return me the sorted form of it. So we are thinking about this step here, that if somehow we have got this, like if somehow we have got in the sorted order, like here we have divided it and at the end we have got it. So in between whatever steps are happening, I do not need to know. I somehow have this thing and this thing in sorted order. So I have divided in the middle. I'm getting the middle index here. And if I'm taking this portion like lower bound to middle, that is lower bound to middle, this is mid, and here mid plus 1 to upper bound. So if I'm taking this portion of this will give me the array in sorted order. So you can see that we are passing a reference to the my array, right? We are not, this is called pass by reference. Since we are passing some kind of pointer, arrays are sent through reference. So if I'm doing any kind of changes in the array, I do not need to return it. It's changed at the location. So I'm having this faith that this function is going to sort this part of my array. So once I have this part of this array sorted, I can just merge that using the algorithm that I showed at the beginning. Like I can just merge them in O of n time. So I am merging this. I'm sorting the left side, I'm sorting the right side from the middle point, and then I'm merging this. So this is all about the merge sort, only this small thing. Now the thing is that you need to know how to merge it. So that's our crucial part here, how we are merging the thing. So for merging, this part you can ignore this part. I have just taken another array because like I said, if you are doing anything, you are passing this array here, and if you are changing this array here, like a of 0 equals, you can put 90. So your the changes will be reflected in the original array itself. So you first need to make a copy, like a new array, otherwise it will get overwritten. Whatever you write here, it will just change the original array. So I have made a copy of the left array. So I have made a copy of the left array, that is this portion. I have made a copy. This one I have made termed it as left array, and I have termed it as right array. Here I have got this value, termed it as left array and termed it as right array. So once I get that, I have copied the array. You can see that. Now what I'm doing, I have this I and J. Like I showed, I have I and J. So this is the length of my left array, and this is the length of the right array. Excuse me. So I is less than length and J is less than length. Like, so I cannot go beyond that. Like, I cannot go after this. So I will be less than the length of array 1 and J will be less than the length of array 2. And if my ith element of array 1 is smaller than the jth element of array 2, then my original array, I'll sort it in the original array itself. So I have this original array itself. I'll place this one first here. After that, I'll increase the value of the marker I as I plus 1. J still remains here. So next time it comes, no, not this. Next time it will be checking between 9 and 23. So 9 comes first. So it goes in that way. So if left array, ith element of left array is smaller, then my element will be the ith element of left array. Whichever is smaller, I'm picking that. So if it j j of right array is smaller, then I'll just put that value at my array, and I'm increasing the index position of the array. So now if some things are left, like you have finished checking one array, like we saw here, we have finished checking this array 2, but we still have these 2 elements left, or maybe more elements left. So we can just place them one by one after that, because we do not need to check between 2 things. They are already sorted. Array 1 was already sorted. So here same thing, left array and right array. So if in case something is left, I'm putting 2 other loops here and placing the remaining elements in the array. So these things get merged this way. So that was all you had to do, like merge these things. And in the recursive function, you are thinking that this thing is going to somehow sort first part of left part of my array, and this thing is going to sort somehow the right part of my array. And then we are calling the merge function and merging them. So if I run it, so you can see that this is sorted. 5, 8, 12, 15, 32, 45, 88, 90. So it's in sorted order. So for visualization, maybe you can see this. If I run this, you have the whole thing array. Wait. So we are splitting the array first. Then we are splitting this array into 455, 81, 2. And then we are again splitting this as long as we can split. After that, we cannot, because that is the simplest case that we get. So now we can merge these things. So we are merging these things. Merged. So same thing here. It's pretty slow. So you understand the thing, like it's merging one by one. So merge. So we'll do the same thing this side. I'm not going to show. We are going to do the same thing this side. And after we get the array in sorted order, we are going to merge those two things and get the array in the sorted order.